Okay, we've got a great presentation lined up for you next. We're going to hear from Strategic Power Systems, an OSIsoft partner, and how they've utilized the Connected Services program to their advantage and to the advantage of their customer, Kindle Energy. The solution that they have delivered is around monitoring and reliability for combined cycle gas turbine systems. Before we hear from Della, I'd like to take just a few moments to talk to the points on this slide. I'd like to start with a brief history and intro of Connected Services to really set the stage. I also want to talk to the service provider challenges. Since this program, the Connected Services, is aimed squarely at supply chain type customers, I want to speak to the challenges or the 5 common questions that we believe they will need to answer. Next, I want to talk about the Connected Services program and the advantages that it brings and how it can solve those 5 questions we talk about in the point above. Finally, I'll have a quick intro for Strategic Power Systems and Della for the real meat of this presentation. As we've worked with our traditional customers, the asset owners and operators, for many years, we've seen in recent years a marked shift in the way that they're doing business. As they're driving more towards operational excellence and intelligence, they're increasingly turning to relationships with trusted third-party service providers to drive value and affect their own bottom line. It didn't take a huge crystal ball to really then consider the need for increased data exchange and intercompany communication to support those service providers, supply chain customers, O&M vendors, and other folks in the overall supply chain. The Connected Services program is designed to fit this communication void. If you think about the theme of this event, people with data can transform their world. At a high level, the Connected Services program is a simple and secure technical and commercial framework that allows service provider companies to access near real-time sensor-based data at customer locations, giving them the ability to transform their world and affect change at the world of their customers. With this commercial offering, the service provider has full access to all the power of the underlying PI data infrastructure, the same PI data infrastructure that our traditional customers, the asset owners and operators, have utilized and relied on for many years. It gives the service provider the ability to collect, store, analyze, and surface both raw and calculated data to drive decisions and add value. As we looked across this connected landscape, we see 5 challenges or common questions that we believe any service provider would need to answer as they ramp up this type of service. First, as a service provider, how do I gain visibility into the processes and assets, think raw data, at remote customer locations? Secondly, as a service provider, how do I deal with the costs and the complexities of data collection and aggregation? Number 3, as a service provider, how do I protect the intellectual property, the value add that I can bring to the equation to keep my solution viable? Number 4 really talks about the complexities of intercompany data exchange that's required to support this type of a solution, specifically when you have disparate organizations, IT groups, security policies, and even differing technologies. And last but not least, how can these service providers maximize the efforts of their workforce and the time that their engineers are spending in the field? The Connected Services program answers these questions with a subscription-based offering that provides many advantages. We believe that this can be a novel market differentiator for service provider companies. It allows those service providers continuous and secure access into remote customer environments, allowing them to see operational data and operating conditions. It allows the service provider companies to collaborate more closely with their customers, leading to a deeper level of trusted relationships and partnerships. It allows the service provider to focus on the intellectual property, the expertise that they can bring to the table. Because it's a subscription-based model, it changes the conversation from a CapEx to an OpEx one, and it can greatly reduce fiscal uncertainty when service providers are looking to ramp up new service offerings. Finally, it helps to maximize the efforts of the service provider's workforce and the time their engineers are spending in the field, with less demands on travel and data collection. With this solution, we believe that the service provider has a substantial opportunity for revenue growth. With this data-driven service, Connected Services can also affect products and services, quality and reliability. For more information about this program, please see myself, Glenn Hummel, or an OSIsoft account manager. I'd now like to introduce Strategic Power Systems and Della. Sal is the founder and CEO and comes to us with more than 40 years of expertise in reliability engineering and information technology disciplines. Strategic Power Systems' core focus is on providing analysis and performance benchmarking for power plants all around the world through a system called ORAP. Let's hear from Sal for the meat of this presentation and how he has affected change for his organization and for his customer, Kindle Energy, using his solution and the OSIsoft Connected Services program. Sal?
Thank you, Glenn. Thank you. Okay, I appreciate the opportunity to speak with you today and participate in this conference. It's been tremendous. This is outstanding. I'm really speaking on behalf of Ed Fuselier, who couldn't be here, from Kendall Energy. He's back at his plants performing some major maintenance that got pushed out during this week, so unfortunately he's not here to participate. He would be telling you a good story about the value proposition that we brought to him. And so I'm going to try to do my best to fill that all in for us. Kindle Energy, by the way, is a third generation of business change. His company, he's the asset manager of 3 power plants at Kindle in Texas, primarily gas turbine combined cycle power plants. And they've changed ownership about the last 3 years 3 times. They were Direct Energy, then they became Lonestar Generation, and today they're Kindle Energy. So he's got a lot of change in his organization, and I'm going to talk about the value proposition that we were able to bring to him to support him and being able to analyze the performance of their equipment. A very brief description of who SPS is first, if you don't mind. Our company is about a 30-year-old business focused primarily on rotating equipment in the power, platform, and oil and gas space. We track the reliability and availability performance of gas turbines, combined cycles, steam turbines. We also do that for renewables, for wind and PV, and in addition to that, for stationary equipment, blowout preventers. Our customers typically are the manufacturers of that equipment. So one of our customers is General Electric, hence a value proposition for Ed to be able to report the data on his GE gas turbines that are in combined cycle power plants in the 3 plants in Texas. The value proposition that we bring to the table is that we're always looking at data. As a 30-year-old business, we have been focused on availability, reliability, thermal performance data, and how that data is used both to drive the manufacturer in terms of how they respond with product updates, upgrades, and improvements, but also how the owner-operator of the equipment is driving their performance. And that's essentially what we're going to be talking about. ORAP as a system is a global system. We're tracking assets all over the world, approximately just over 3,000 rotating assets in both 50-cycle and 60-cycle applications. The value proposition that brings is when Ed looks at his data for 7 FA combined cycle and 7 EA combined cycle, he can compare his performance to his peer groups. Natural gas operating units, either in cycling, base load, or peaking duty. And that's the value proposition that ORAP brings to Ed. What I'm going to talk about briefly is the kind of data that you need to do that benchmarking comparison. And ORAP wants to look at 4 kinds of data. It needs configuration data. What does the power plant look like? If it's combined cycle, what equipment is inside that plant? Who's the HRSG provider? How many pressure levels does it have? Who's the steam turbine provider? What's the size, et cetera, of that equipment? So configuration is a very, very important part of benchmarking when you compare the metrics that, say, Ed's plants are achieving versus like units. He has 2-on-1 combined cycles, 7 FA, 7 EA with Volt boilers. His Frontera plant just outside of McAllen, Texas, provides power in that area, but uniquely he's now selling power into the Mexican market. As that market liberalizes, he's actually added they've added some high voltage lines to be able to migrate power down into Mexico. The other kind of data that we need is event data, outage events, maintenance events, forced outage events, how long it takes to repair things, what components are the cause of that downtime, etc. That's human input. You're not going to get away from human input. But age characteristics and operations data are information you can pull from your historian, PI in this case. We're a proud partner of OSIsoft through the Connected Services Agreement, and that allows us access to data if they have PI on site, or even if they don't have PI on site, we can get access to the control or to the other historians to pull the near real-time data so we can transform that data into time, capacity, and events. And that's essentially what we're doing with the data. We pass that data through over 600 automated data validation rules to validate that data and improve the fidelity of that data. But at the end of the day, the data transformations that are key are the aging characteristics that at the end of the day on the 7FA gas turbine are no longer just human input or input from counters. They're complex algorithms that require information about ambient conditions, load conditions, and various other elements that drive the aging characteristic of that unit. So this benefit gives Ed the opportunity to standardize across his fleet. It allows him to benchmark and develop KPIs that are meaningful for his business, both from a financial perspective and from an engineering perspective. And it allows them to have strong communication with the manufacturer to drive his success. And that's the value proposition that the PI Connected Services Agreement gave us with Ed as we developed this process. The challenge that we had in supporting Kindle Energy, those 3 plants that we just talked about, was to reduce manual input, which is tremendous, improve the data fidelity and quality of the data, and improve the timeliness of the data. The way the system worked for Ed, every week his management team wanted to see information on how those plants performed. Were they making money or were they not making money? And those 3 plants would report into corporate, and at the end of the day they had disparity in the metrics that they were providing. They had to justify their numbers, and it was difficult to justify them. And at the end of the day, there was some level of uncomfortableness with respect to, are these accurate metrics? A gas turbine, at the end of the day, has, just like any other rotating equipment, a start cycle, an operating cycle, and a shutdown cycle. If you want to know how much fuel you've used during your startup cycle, where you're not generating any power, you're not going to get that from your operator without a lot of work. The control system can give you that instantaneously. So the opportunity to optimize data collection was enormous. And that was the opportunity that was in front of us. This whole process actually started back in 1994 with an EPRI project that was focused on Potomac Electric Power, and we were able to demonstrate, check the box, that we were able to collect data from PI. PI was already at that site, and transform that data on a local server into the metrics some of the metrics that we just talked about. With the Connected Services opportunity, we began conversations with OSIsoft, and we were able to formulate a partnership in 2011. We began that process in 2015, closed that process, and today we now have a scalable process that we can take to all of our customers, those 3,000 units that we showed you earlier, and like for Ed, provide productivity improvement that at the end of the day saves them money and improves the fidelity of their system, their data. The Kendall Energy solution looks just like this. There's the plant sending in data through their control system into the PI system. And by the way, it's a GE system. They have, at the various plants, they might have an Emerson control, they might have a Prophecy. It doesn't really matter. It doesn't matter what the control is. We're able to pull that data through Connected Services into PI, bring those data points from the plant in a secure manner, SIPS compliant, SIPS 5 compliant, and then process that data in our data center back in Charlotte, North Carolina. Do I sound like I'm from North Carolina? Not too much, but I'm happy to be there, let me tell you that. It's a great state. And at the end of the day, we transform that data into those metrics that we just talked about. And the value proposition is the fidelity of the data. I could look at a start, how long it took that turbine to start. I know when the start signal was given. I know when the permissives were executed. I know when fuel was injected and ignition took place. I know when you got breaker closure because you were now at a synchronous speed, in this case 3,600 RPM. The value proposition is enormous. And the value of leveraging that data for Ed to prevent him from having to do that by human effort was exactly tremendous. It saved him a lot of effort and improved the fidelity of the data. What did it do for Kindle? And how do they use the data? Today, Ed no longer generates weekly reporting to his management. He no longer generates that by hand. He generates it through this system. He's able to look at every one of his operating missions from the time I start the machine to the time that I do a safe shutdown or maybe have a trip. Every one of the operating missions are captured in the system. You know what the impact of those missions are on the age of the equipment. I can track my hot gas path parts and the impact of those starts and stops and cycles on the lifetime of those parts. Those parts today cost between $4 and $7 million for a set of rotating first stage rotating blades. It's a lot of money. If you're going to manage that fleet, you better have the operating characteristics correct so that you know when you need to do maintenance. You know when you need to, because their cycle's limited. I can do 3 repairs on those parts and I've got to scrap them. If I do it too early, I take out life. If I do it too late, I've not taken enough life out that I should. Ed now has a process that lets him operate his plant and make money. Another tremendous opportunity is, how many of you are familiar with NERC GADS? NERC GADS is mandatory, right? At the end of the day, you have to report to NERC. This system does it for you. You've already captured the data once. Why do duplicate data entry? It does the reporting, it converts it to the NERC format, and it sends that data to O80 so they can add it to their database. It's validated, it's processed, and it's ready to go. We have a relationship with NERC as a data reporting entity to allow that process to happen very efficiently. And on behalf of Kindle, it takes work away from Ed's group. Tremendous opportunity. The ability to benchmark against a peer group allows Ed to see how his frame 7s are operating against the peer group of his choice, based on age, based on fuel, whatever he chooses. And now, with another relationship we have with a company called MapEx, we can do thermal performance monitoring that allows Ed to look at the thermal performance of his unit just as he looks at the reliability performance of his unit. So he can look at the compressor efficiency. Is degradation taking place? When do I need to water wash? Is it mechanical degradation that's not recoverable until I do an upgrade or a maintenance repair? That system now allows Ed to drive his strategy for maintaining his equipment. You can look at interstage temperatures, stage 1 to stage 3 in this case. And tremendous opportunity to look and marry reliability, maintainability, and performance together to allow Ed to drive his plant profitably. So what did it do? What does the Connected Services Agreement allow us to do? It gives us access to the real-time data. The fact that OSIsoft has a tremendous share of the North American market is a value proposition that allows us to scale this approach for all of our customers and improve their process of data reporting and improve the fidelity of the data. By tying that in with the 30 years of experience that we have from a reliability engineering and a design perspective, we're able to leverage that data on Ed's behalf so he no longer has to anticipate events. He can almost begin to predict events. Because in the long run, what's the next step for Ed? Predictability. We talked about that, or we heard that this morning. Being able to predict when events happen so you don't just have to wait for alarm limits to be passed. You start looking at the data to allow you to take action where you know you need to based on information available from the system. Tremendous opportunity. The built-in transformation logic allows you to do things that you never ever could have done before. I can now anticipate events based on the history over time of what's taking place with my machine from the perspective of an embedded fault tree. So it's a cohesive vision that allowed Kindle Energy to allow them to gather data, the gems of knowledge available in the data, to transform that data into metrics that lets them run their business. It's a cohesive strategy that lets them rely on the algorithms that are based on the equipment that they're operating, so that as they transition from a GE machine, perhaps, to Mitsubishi in the long run in the future, this system just is using asset framework, duplicate the process, change the data tags, and you're up and running with the system. Tremendous opportunity. Connected services gives us the scale and the opportunity to pull that data down quickly. It takes, instead of days to get this thing started, it's hours to get it started. So again, on behalf of Kindle Energy, and I do wish Ed was here to present to you, because he tells me a story that I have a difficult time repeating, but I'll try to repeat it. He'll tell me that, Sal, you know, I'll get telephone calls from my managers, and they need information as quickly as they can get it. And in the old days, I would take hours to go get that data. It now takes me minutes to go get that data. But I don't give it to them. I hold on to it for an hour. I take a look at what's going on around my plant, and then I get them the data in an hour and a half, and I look like a hero. But I could have done it in 10 minutes. I told you at the beginning of this thing that they changed ownership several years over time. Where did the data come from to support the due diligence that the other buyer was getting to be able to determine how that plant operated over its history? And was the buy decision of buying these assets a good decision? They were able to use the information available in the ORAP system to help support those buy decisions. So if Ed were here, he would tell you, look, his greatest challenge was people. It takes too much time to get access to data. And by the way, he has had Pi in his plant for many years. He has used process book to analyze the data. He was a tremendous advocate of the Pi system, and he's a tremendous engineer. But he needed to start to move quickly. And that was an issue that confronted him. The solution was, let's take the data from Pi, transform it, and let's turn that into an asset that you can help run your business with. And at the end of the day, the value proposition is it saved 85% of the labor that he used to have a results engineer perform every week. It saves that labor. That engineer can now be redeployed to other maintenance activities, the things that human intelligence really needs as they operate and maintain that plant. He now has 85% of that person's time freed up. A tremendous value proposition. And that is a story that, at the end of the day, I wish you heard from Ed, because that's the story he's told us. And in fact, it's real. So with that, I want to say thank you for the opportunity to present to you. I've known Ed since 1978, when he was with Houston Lighting and Power. In the industry, he's probably one of the most recognized leaders from a technology perspective, and a great friend, and appreciate his support. He's an early adopter. It took an early adopter, the vision, to say this is the right opportunity to gather value through Pi and the Connected Services Agreement to help him run his business. So again, thank you very much. I'm happy to address any questions you have, and if you do have a question, they would like you to state your name and use the mic. So Glenn, thank you very much.
Okay, any questions? We have one here. Do we have a mic runner?
Where?
Go ahead, maybe we can hear you. Oh, here it comes.
I don't know if Kendall has, for example, advanced applications such as automatic generation control or
AGC.
unit commitment and things like that. And if they do you send some of these information, for example, some of these old generators have a rough zone. When they pass through this rough zone, the ramping has to be maximum, or maybe the best place for the base point, or even the cost of the startup and shutdown. Do you send this information automatically to these advanced applications, or no?
It's a one-way flow of data from the applications into our system, but in terms of, do they have AGC? They do. So they are on generation control, automatic generation control. They have they don't have a rapid start requirement, and they're in the ERCOT system, so they don't have capacity payments. So they have to start, and they are a non-utility generator, so they're serving a market on a competitive bid-ahead basis. They bid ahead. With the change in their marketplace, vis-a-vis the opportunity to sell power into Mexico, that changes some things as well, because if they sell now into Mexico, they can no longer serve the ERCOT system in a similar fashion. So they have to have a disconnect. But all of that information is available in the system at the scan rates that are required, and then we transform that data. But there is no direct feedback back to AGC. There's no direct feedback to the dispatch. That happens from their own internal systems. Thank you. Any other questions?
Volkmar from Tower Power. I have a question. You were talking about a gas plant here as an example. What about solar plants where you have non-moving parts?
Very good. Yes, good question. Yes, same process to track information from the SCADA. So you're not dealing with moving parts per se, but you are dealing with equipment that has aging characteristics. And at the end of the day, you want to now follow different standards. In the rotating equipment world, you want to follow the industry standard. IEEE 762 is a industry standard for looking at the reliability of fossil steam plants. In the PV world and the wind world, there's an IEC standard. And you take the data points from the SCADA and you transform those data points and you bucketize them per the IEC standard. And so in a gas turbine plant that's running in a peaking mode, reserve standbys are very important. You're going to need to track your reserve standbys properly. In the IEC world, you're going to bucketize things similarly with that description of what they do with reserve, but they look at whether in wind, is the wind blowing at the right level? Can it generate power? Is it between 3 meters per second and 7 or 12, whatever the upper limit is, 25? And where does it fit in that? With the sun, it's also different standards. But so yes, you still rely on the data available from the historian, and you transform those data points into that standard. My pleasure.
We have one right here.
Sir.
Yeah, I heard you talk about calculating thermal performance for a wide variety of different power kinds of plants.
Yes, sir.
But I didn't hear nuclear. Is there a reason?
Yeah, we have not done nuclear. We've stayed away from nuclear because it's highly regulated. INPO is in nuclear. There's a lot of reporting already required for nuclear. My expertise is gas turbines, combined cycles. And so when I formed this business, that was my first focus. I'm an ex-GE person. That's where I came from. Don't hold that against me. It was a good learning experience, tremendous learning experience, but it's a different place. But the market is different, isn't it? So we've never focused on nuclear. We may sometime in the future, but that's not our core competence. Thank you. Any other questions that I can address?
Yes, Steve Irby from Exelon Generation. So I heard you mention gas, power gas. Anything
sir.
with wind gas that you're doing
Yes,
as
sir.
well?
Yep, there's a wind working group that NERC has been driving. We're active in that working group as well. There is a continuing change in the schedule. They keep talking about wind being mandatory by this point in time. They started that in 2014. It hasn't yet hit. It's going to hit sooner or later. So the objective is we've helped in that process by leading them down to the IEC standard, which lets you bucketize the data in a more more proficient manner. It's not like fossils, so you got to have some levels of disparity. But IEC standard is embedded in the new process. I think that the NERC GADs there will be a requirement for wind probably in 2017, 2018.
Okay, thanks. Just one final question
Yes, sir.
around NERC SIP. Any generation assets that you're doing that has any NERC SIP compliance aspects to it?
Say, I apologize, I didn't hear that.
NERC SIP,
Yes,
NERC
sir.
Critical Infrastructure Protection.
Yes.
Any NERC SIP implications with any other generation assets that you're kind of monitoring?
Not now. We've passed NERC SIP's compliance, so NERC SIP's 5, we've passed that. So we're pretty confident that any changes we'll pass that. We work very closely with NERC at the leadership level because our data somewhat mirrors their data, so we have a data sharing relationship as well. The difference between their data and our data is fidelity. I want to look at a problem with a speed sensor. They want to look at a problem with a system because they're really at the generation mix level and I'm at the component level. But that's the only difference. Have I addressed your question, sir?
All right, we should be just about out of time, so thank you very much, Sal.
Thank you. Thank you.
About a round of applause.